Here we go with video 8. We are going to talk specifically about the process of the digestion of the fuel nutrients in not just the small intestine, but starting from your mouth and working its way down. Now remember, most chemical digestion and absorption do occur in the small intestine, so obviously that's going to be the focus for all three fuel nutrients that we are going to talk about. And when I say fuel nutrients, at this point, you should know what three things I am talking about. All right, so we're going to first focus on carbohydrates, sugars. So you've seen this picture before. We start with starch. We might start with individual glucoses. If you're eating candy, then not much digestion has to occur. Not much chemical digestion has to occur, just absorption. But let's say you start with starch, okay, like we talked about with potatoes. Remember, there's going to be enzymes. You should now know about enzymes. They're proteins. They speed up chemical reactions, so on and so on. Most of the enzymes for the digestion of carbohydrates are going to occur in the small intestine. We're going to break this starch down into monosaccharides, into glucoses and other monosaccharides, and then you're either going to restore them, in the case of humans and animals, in the livers and muscles, as glycogen, or you're going to use it as energy. Okay? So now we're going to take this from the mouth down through the small intestine. So we talked about how salivary amylase, an enzyme in the saliva that actually will start the chemical breakdown, of sugars, not a lot of it, a very small amount, and then, as with all the fuel nutrients, you're going to finish the chemical digestion of carbohydrates through pancreatic amylases in the small intestine. So these monosaccharides, so we break down these polysaccharides into monosaccharides or disaccharides into monosaccharides. They then, as monosaccharides, are able to be absorbed into the bloodstream through a process called active transport, which you should recognize. So it takes energy to take it from your small intestine into the bloodstream and then to the liver. Okay, then to the liver. If these carbohydrates are needed for energy, so let's say you're doing a lot of physical activity, you're breaking down this glucose, then it's going to be sent to your bloodstream, sent to the cells that need it, and you're going to use it as energy. Remember, the brain can't store glucose, so we always have to have some glucose in the bloodstream in order to keep the brain happy. It uses glucose as an energy source. If it goes too low, your brain can't store it, so it has to have it from the blood. It has to have it from the blood. If you don't need the energy, obviously you're going to need some of the glucose for the brain, but if you don't need it and you have a bunch of it, then you're going to store it in the liver and the muscles as glycogen, okay, as glycogen. So let's say you're eating a lot of carbs, but you're not working out, you're not exercising, you're not burning it, then yes, you're going to keep some in your bloodstream to be used by the brain, but then you're going to store it as glycogen. Now let's say your liver and muscles are full of glycogen and there's no room for anything more. Then what it's going to do, metabolically, it's then going to convert this excess glycogen into fat, into triglycerides, and you're going to store it. And you're going to store it. Okay, and you're going to store it. Okay, so we've talked about how your brain needs a constant supply of glucose. So we've talked about homeostasis many times. Okay, many times. Maintaining homeostasis, keeping your glucose between the high and low level. We've had that discussion before. Your pancreas, remember we talked about the exocrine part where your pancreas is going to secrete enzymes that are going to help digest these nutrients. Well, you have the endocrine part of the pancreas, which it's going to secrete insulin and glucagon to maintain proper glucose levels. So, when you have high glucose, when your glucose levels start to go up, to keep it from going too high, what's going to happen is the pancreas is going to secrete insulin, and most of you have heard of insulin. Okay, we talked about insulin somewhat when we talked about receptors and channel proteins on cell membranes. What the insulin's going to allow your body to do, it's going to allow your muscles and liver to take in the excess glucose. So as your blood glucose starts to go up after a meal, you secrete insulin. The insulin lets that glucose that is in the blood go into the liver and the muscle cells, bringing your blood glucose back down. Okay. Remember, glucose goes too high, it's bad for your brain. Goes too low, it's bad for your brain. So this part is keeping it from going too high. This is the endocrine job of the pancreas. Too much blood sugar, bad for not only your brain, but also in your nervous system, but also your capillaries. Which we have not talked about yet, but the little capillaries, the little blood vessels, they don't like too high blood sugar. So your brain doesn't like, your nervous system doesn't like high blood sugar, your capillaries don't like it either. They can actually wear away at those nerve endings and capillaries, and the capillaries can become leaky, the nerve endings can start to die. But what happens when your blood sugar gets too low? Most people are familiar with insulin, but they're not as familiar with the second hormone secreted by the pancreas called glucagon. So what happens is, let's say you haven't consumed a large amount of glucose in a while and your blood sugar starts to go down. You're still in the normal range, but it's going down. What's going to happen? Your pancreas is going to secrete the hormone glucagon, which is going to cause the liver and muscles to take glycogen and convert it to glucose, and then put the glucose into the bloodstream. Okay. So that's going to raise your blood sugar. So insulin and glucagon are normal, healthy hormones that keep your blood sugar in that normal homeostatic range. Not too high, not too low, but in the range. And it's going to go up and down during the day. Okay, during the day and in the evening. It's going to keep it all the time in that normal range. And those hormones are going to work to do that. So insulin and glucagon are part of a negative feedback system. All right, they keep things working towards set point. Okay, working towards set point. All right, so how are lipids or fats going to be broken down? You've seen this picture before. Here's a triglyceride. Enzymes are going to break that down. Again, in the small intestine. Okay, in the small intestine, we break that bond between the glycerol and the 3 fatty acids. Okay. You're either then going to use it to make energy. Remember, fats can make a lot of energy. Or if you don't need it to make energy, then it's going to be stored as adipose tissue in adipose cells. Okay, adipocytes, also known as fat. So what's going to happen? Fat is going to start to be digested in the small intestine by emulsification, which we've talked about. Mechanical digestion, taking the bigger fat blobs, making them into smaller fat blobs in the duodenum of the small intestine. Okay, in the duodenum of the small intestine. That's going to increase the surface area. So then we have lipases, enzymes from the pancreas, are going to break down the 3 fatty acids and the glycerol in the small intestine. So now we have the 3 fatty acids separated from the glycerol. Bile salts are then going to surround these 3 fatty acids and glycerol. These are called micelles. And then it's going to be absorbed into the epithelial cells of the small intestine, okay, that mucosa layer. What's going to happen is, to keep it simple, basically the fatty acids are going to be put back together again. Okay. Put back together again, bonded with a protein called a chylomicron. Now we're in the epithelial cell. Okay, we haven't been completely absorbed yet. Then what's going to happen, this chylomicron is going to go into the lymphatic system, okay, through the lymphatic system into the bloodstream. So carbohydrates were absorbed through the bloodstream. Fats are going to be absorbed through the lymph system, okay, the lymphatic system, into things called lacteals. Ultimately, they will end up in the blood, but when they are absorbed through the lymphatic system. This just shows a picture. Okay, we're separating here in the intestine. We have enzymes, lipases, that break down the 3 fatty acids from the glycerol. They then absorb into the epithelial cells of the small intestine, are put back together, and then with proteins called the chylomicron. Then it goes into the lacteal, which is part of the lymphatic system, where it is absorbed. Okay, where it is absorbed, and taken away from the intestines. Okay, taken away from the intestines. So the big difference here is that it's not absorbed directly through the bloodstream. Proteins are going to be broken down by enzymes. Again, it starts in the stomach somewhat. Starts in the stomach with the enzymes in the stomach. Then it's most of the digestion, just like everything else, is going to occur in the small intestine. The enzymes from the pancreas secreted into the small intestine will take a long strand, a polypeptide of amino acids, and break it down into smaller dipeptides, tripeptides. They are then small enough to absorb into the bloodstream, into the bloodstream. So we break down these into a single amino acid or to dipeptides, tripeptides. They then get absorbed. They get absorbed into the bloodstream, head to the liver, very similar to carbohydrates, except now we have proteins, which are made of amino acids. So again, break down a polypeptide, a large protein, into smaller units. Those units are then absorbed into the bloodstream and then taken to the body. Okay, we're going to go into a couple other definitions. Anabolism is large molecules are built from smaller molecules. Catabolism is the breakdown of large molecules to small molecules. What we just discussed, taking these large molecules, whether it's triglycerides, whether it's polysaccharides or proteins, and breaking it down into small units, that is catabolism. So what we just talked about is the breakdown of foods in the digestive system is an example of catabolism. Anabolism is taking small molecules and building them up into large molecules. So for example, these amino acids, when you look at people that are training and trying to build muscle, they will take these protein supplements. What they are trying to do is consume proteins, consume amino acids, get those amino acids into their bloodstream, then to the muscles, and then taking those amino acids and building muscle. That is anabolism. You are building things. You are building things. So you're taking a bunch of Legos and you're building a big Lego model. That is anabolism. Let me go back to this real quick. So when you hear about anabolic steroids, anabolic steroids, which do exist naturally in the body, but some athletes trying to build muscle will take anabolic steroids. What those anabolic steroids do is they promote the buildup, the building, in this case of muscles, of muscles. So that's anabolism. You also have an absorptive and a postabsorptive state. These all kind of tie in together as we go through this. Absorptive state is the time during and shortly after eating. This is when you have nutrients flowing through your bloodstream from your small intestine. So you've consumed the food. These nutrients are going through your bloodstream. All right, so a few hours after eating, after you absorbed nutrients. Post-absorptive is when the digestive system is empty and you have to get the energy. You have to get the energy or the nutrients not directly from your intestines, but from what you have stored. From what you have stored. So you haven't eaten in several hours, your blood sugar may be going down. Where are you going to get those nutrients? Where are you going to get the nutrients? How are you going to bring your blood sugar up? That's the post-absorptive state. So we're going to go through each nutrient. So we've talked about glucose travels through the liver. It travels around the bloodstream. It's used by the brain. In the absorptive state, this is what happens. You get the glucose, small intestine, into your bloodstream, travels around the bloodstream, used by the brain, can be stored. If you have too much of it, then your body's going to store it. And it's called glycogenesis. Genesis means the formation of. This is glycogen. So what will happen is, and we've talked about this, is the glucose will go to your liver and your muscles. It will take the individual glucoses. You're going to build something up. It's anabolic. You're taking the glucoses, putting them together, and making glycogen. And this is going to be stimulated by insulin. All right, so remember, glucose level goes up, insulin secreted. The insulin causes your liver and muscles to take in this glucose. You've got plenty of it. So your body's going to go through glycogenesis. It's going to make glycogen. It's going to take all the glucoses, put them together, store them in the liver, store them in the muscles. That's the absorptive phase of carbohydrates. Now, if you have too much glucose, and I've said this before, and you have too much glycogen, then what your body will do, and there was a time, and you guys aren't old enough to remember this, when I first started teaching, we would teach nutrition, we taught, you can't eat fat. Fat is bad for you. But so what people were doing was they were eating all this glucose. They were eating glucose, they were eating, fat-free things, but had a lot of glucose in it. So what happened was they were still gaining weight, and they're like, how can I be gaining fat when all I'm eating is glucose? Well, what the body does, remember we talked about how as human beings, our metabolism is designed to think that in the future we will have a state when we are starving. So what it will do, it will take all the nutrients we have and it will store it for a future time when we may not be eating. Okay, when we remember our woolly mammoth, where we don't have any woolly mammoth to eat. So again, if the glucose, there's too much of it, and the glycogen in the liver and muscles full of glycogen, it's going to take that glycogen and it's going to convert it into fat and then store it as fat. So again, a low-fat diet does not necessarily mean you're going to lose weight. You can actually still gain weight if you're still taking in more calories than you are using. All right, the post-absorptive state. So when you haven't eaten or consumed carbohydrates recently, when your blood sugar gets low, you must increase it, remember, for the brain. So what's going to happen is glucagon, remember glucagon, don't get glycogen and glucagon mixed up. Glucagon was the hormone secreted by the pancreas when your blood glucose levels started going down. What's going to happen is glucagon, your blood glucose starts to go down, your pancreas secretes glucagon, you're going to start to break down that glycogen in the muscle and livers, break it down to glucose and put it into the bloodstream. That way the brain has what it needs and your other cells of your body will have the glucose that it needs, and you keep the glucose in a normal range. So this is what happens when you have not consumed glucose immediately. So several hours after eating, overnight. Okay, when you're not eating food and you're asleep, your brain still needs the glucose. This is how it's going to get it. All right, fats. You've just consumed a meal. Okay, so we're in the absorptive phase. What's going to do, if you're using fuel and you need fuel, so if you're exercising, doing aerobic exercise, then it's going to put the fat into the bloodstream. Okay. And you're going to use it as an energy source. Many times when you consume fat, you don't usually using it right then, even though remember we talked about your heart needs it. What's going to happen is if the fat's not being used, your body will store it as triglycerides in adipose tissue. Okay, and those adipocytes, that adipose tissue that we talked about when we did tissues. So lipogenesis, we're forming fat. Okay. Now where you store that fat is going to differ from person to person. Males and females store it differently. Person to person stores it differently. So again, your body is storing it because you're not using it. It is storing it for somewhere down the road, which usually doesn't exist, when you're going to be lacking calories and need it. So what happens if post-absorptive? So you have not consumed fats in a long period of time and you need it. Well, what's going to happen is if you're burning more calories than you have in your bloodstream, your body is then going to start breaking down that fat, putting it in your bloodstream, and then your body will use it. Okay? So when people are trying to lose weight, they're trying to get to a point in a healthy way where they are trying to break down fat that they have to use for energy in their cells. If you're always taking in more calories than you need, your body's going to store it. If it's glucose and you've got too much of it, it's going to store it as fat. If you're taking in too much fat and not using those calories, it's going to store it. The goal when you're trying to lose weight is to be burning more calories and to use that fat storage that you have to supply your cells with energy so you're breaking it down. And that's lipolysis. Lysis means to break down. Now, just a side note here, that in order to burn fats, you have to have carbohydrates. So you have to have glucose in order to burn fat. Fats burn in the flame of carbohydrates. Now this is, to understand this, you got to understand more metabolism, and we'll talk about this in a later video. But just trust me that you need carbohydrates to burn fat. So, don't worry about this one. But if your body's trying to burn fat and you have no carbs, you can get into a dangerous situation. You can go into what's called ketoacidosis, and you can form what are called ketones, which can be dangerous. So in order to burn fat, you have to have some carbs. So the danger in going on a really low-carb diet is that you can't burn fat efficiently because you don't have carbohydrates, okay? Because you don't have carbohydrates. Ketones can cause problems. They can cause your pH to change, which can cause problems. So high-protein diets, someone who's diabetic can have this issue. We'll talk about this more as we go along. One way you can tell if someone's in ketoacidosis, especially someone who's diabetic, which again, this will make more sense later, they get a sweet smell to their breath, and many times they'll almost act like they're drunk. So sometimes people that are diabetic that are having an issue because they don't have enough sugar, people can actually start to think that they're drunk by the way they're acting and how their breath smells. Okay. All right, proteins, absorptive. You've just consumed a meal with proteins in it, amino acids. Post-absorptive, what's going to happen is if you're building muscle, your body always needs proteins, amino acids to build things, to build muscle, to build neurotransmitters, to rebuild things. That's the absorptive state. Post-absorptive, if you're in a state where you don't have sufficient protein in your diet, your muscles can be broken down so the amino acids can be used. If you get in a really low glucose state, you don't have a lot of glucose, your body can use proteins to make energy. I think I've said this before, but it's not a state you want your body in. So you really don't want to be breaking down muscle in order to make energy. Okay? And I've said this before too. You don't really want to be breaking down proteins or muscles to make energy. So it's really not a good state to be in. Okay. All right, so I'm going to stop there. The next video will go over what happens in the large intestine. Okay, in the large intestine, again, check your objectives to make sure you can answer those over this video. Okay, the end.